So this is another video where we're going to be working with explicit functions. This time we're going to work with some geometric sequences though. So in order to figure out what's going on, if it's geometric, remember you can use that next divided by previous to help you figure that out. Some of you may look at this and go, oh, I already know what's going on. 180 to 60 divided by 3, 60 to 20 divided by 3. If you take 20 divided by 3, you get 6.6 repeating. Yeah, dividing by 3 does work for this pattern, but whenever we talk about geometric sequences, we want to think of it as a multiplication pattern. So next divided by previous can help us figure out what it multiplied by. So I would do next is 60 divided by previous is 180. Now you could divide that out and get a decimal, or you can also simplify it down as a fraction. Dividing by 10, we get 6 over 18. You can also divide by 6, that would be 1/3, is our growth factor. So every step it takes here multiplies by 1/3. When I go to write the explicit function for this then, I'm going to start with t of n equals 180. That was our first number we knew. Remember, I'm not just saying term 0 or term 1 makes 180. I'm wanting to say any term starts from that 180, and then since this says it multiplies by 1/3 over and over again, I'm going to put times 1/3. And then if I want to repeatedly multiply, the way we represent that in math is with an exponent. If I wanted to say 1/3 gets multiplied twice, I'd put a power of 2. 1/3 gets multiplied 10 times, I'd put a power of 10. So in this case, since we don't know how many times we're multiplying by 1/3, we do it over and over again. We're just going to use an exponent of n there to show that it's going to repeatedly multiply 180 times 1/3 over and over and over again until we get to the term we want. Then the domain, since this sequence started with term 0, and you can use this to help you find that, we're going to say n is greater than or equal to 0. It's unlike the recursive function. The domain for the explicit function includes all the terms starting right from the very beginning. So that right there is the first thing it asked me to do, was write the explicit function. The second thing it asked me to do was use it to find the value of term number 6. So if I want term number 6, that would be t of 6. Remember, the n here was standing for the term number. So term number 6 equals 180 times 1/3 to the 6th power. Now, order of operations tells me to multiply that exponent out first. So 1/3 to the 6th power. You could do that repeatedly on your calculator, but most of your calculators should have an exponent button. So if I just typed in 1/3 to the 6th power in my calculator here, I got 0.0013717421. While it is a good idea to round, I don't like to round until I'm completely done with the problem. So I'm going to wait one more step because I still need to multiply that by 180, and then I'll round the result. So I've done exponents. Multiplication comes next in the order of operations. So multiply that by 180, and now I round the result, which my calculator says 0.246, so I will round that to 0.25. So t of 6 means the 6th number, if I were to keep this pattern going, would be about 0.25. Let's take a look at the second problem now. Again, this is a geometric sequence. You can probably figure out the pattern just by looking at the numbers here. 5 times 2 makes 10. 10 times 2 makes 20. 20 times 2 makes 40. So this is a doubling pattern. So when I go to write my rule, it's going to say u of n equaled 5 times 2, because it's going to multiply that 5 by 2 over and over again. And then we use an exponent to say how many times to multiply by that 2. Now here's where this one gets a little tricky. Because if I just put n here, term 1 would tell me to multiply by 2 once. I don't want to multiply by 2 yet on term 1, so I take 1 away from that exponent. So my exponent there is going to be n minus 1. Anytime you're starting on a term other than term number 0, like here we start with term 1, you're going to have to use that to help you line things up correctly so that term 2 would multiply by 2 only once. Term 3, when I put a 3 in there, would multiply by 2 twice. And term 4, put in 4 there would make an exponent of 3. And you can see term 4 we had to multiply by 2 3 times. So that works. My domain then says it works when n is greater than or equal to 1. Again, because we started from that term number 1 there. So there is my explicit function. It also told me in my instructions, use it to find the value of term 10. So u of 10 will tell me that. 5 times 2 to the 10 minus 1 power. So can't really do the exponent until I do that subtraction. Need to know what 10 minus 1 is. So I started with that. 5 times 2 to the 9th power. And if I grab my calculator here, I do that exponent. 2 exponent 9, 2 to the 9th power is 512. And then we multiply it with the 5. I'm running out of room down there, so I'll come over here to write my final answer. U of 10, the 10th number, I got from multiplying those two was 2,560. So if I keep this pattern going out to term number 10, that's the value you would get.